Okay, so we are moving on in Unit 3. We talked about distance formula and midpoint formula, so coordinate geometry. And we're going to take a little bit of a sidestep here just to talk about linear equations. A lot of times with IB, because it's applications, it's bringing all sorts of different areas of mathematics together to bring it into this idea of the fully applied mathematics. And with that, there tends to be a lot of overlap on content, as we've seen in previous classes about like systems of equations kind of coming up in our class without really talking about it. And another thing that's going to come up is equations of lines in this unit, and we're just going to have to talk about it in order to be able to know more about what we're talking about later. So we just need to talk about a few things with equations of lines, and then we're going to move on to talking about parallel and perpendicular lines, and then we're going to be able to talk about the ultimate goal of this unit, which is Voronoi diagrams. All right, so the first thing, the most important thing about lines is the gradient of the line. The gradient is really just the slope. So you may have heard gradient before, you may have not. If you have not, it just means the slope. It's just a different word for that. So we have formulas that can deal with the gradient of a line. This, I believe, is in your formula packet. Just remember that m tends to represent our slope, and the idea of it is it's the difference in your y values over the difference in your x values. A lot of times the difference in your y values is the rise that you will experience when you're following these points, how far you're going up or how far you're going down. The rise, just change in y values. And then your difference in your x values are your run. I'm sure everybody's heard that, your rise over your run. And so it's representing the difference in your y values over difference in your x values. A lot of times we call that delta y over delta x. Delta means change in or difference. So how something changes, how these values change, which tends to be their subtraction. And so then we have a formula with this. The difference or the change in them just means that you need to subtract those values, which means I could do y. Typically, it's y2 minus y1 over x2 minus x1. This means that you need to have a very specific way that you subtract them, right? This idea of you take the second point and the first point, you take the first point and subtract it from the second point. Sorry, that took me a second try to attempt to say, but it doesn't necessarily have to be like this. You could do y1 minus y2. That's totally fine, just as long as you also flip the denominator. You just need to be consistent in which values you put first and which values you put second. The only thing that's going to change is the sign. If you flip the top and then don't flip the bottom. So if I did y1 minus y2 over x2 minus x1, what it will change is the sign. If it's positive, it'll become negative. If it's negative, it'll become positive. And so that's just something to be aware of. We have all sorts of different types of slopes, but just to visually understand what these slopes mean, we have a positive slope. And we always read this from left to right. I don't know if my camera's flipped when you eventually watch, but from left to right, it rises. Versus negative, reading left to right, it goes down. We can also have a slope of 0. A slope of 0 has to mean that it was 0 over something. Remember that you cannot divide by 0. So if the slope was equal to 0, that means that the number in the numerator was 0. And if that means that the numerator is 0, that means that your y values don't change. You don't rise at all, you only run. An m equals 0, a slope of 0 is just a horizontal line. That's a pretty terrible horizontal line. Maybe a little bit better. So it's just a horizontal line. So then if we wanted to talk about a vertical line, your run would be numbers. It could be a variety of different numbers, but realize that you don't run at all. On these points, you're not moving from left or right, you're only jumping, which means that your run is 0. And we cannot divide by 0. So then that means that your slope is undefined. Okay, so you can have just a normal positive slope, you can have a normal negative slope, you can have a 0 slope, which is just a horizontal line, and then the perpendicular slope to a horizontal slope would be a undefined slope. So these guys are perpendicular to each other, and those are the two kind of special cases of our slope. Okay, so please make sure that all of this is written in your notes. We're going to go ahead and practice this for in like a very straightforward way and then in some very IB ways. We just need to determine the gradient or the slope of the following lines. So when we're looking at a graph, when we're trying to find a slope, our first goal is to find values on this line that fall really nicely on a crisscross of the grid. And what that means is that if I were to pick like right here, notice that it falls on this line right here, but there isn't another cross right here for me to easily understand what value that is. Maybe it's 3.5, maybe it's 3.4, I don't really know. And so what I'm going to choose instead are values that look like they might go through something that I can read, right? That point I can read, that's 2, 5, right? This point I can read, this point I can read, this point I can read. Okay, it does not matter which 2 points that you choose. You don't have to choose points that are right next to each other, but you do need to make sure that you simplify your fractions, and you'll notice that the simplification of these fractions will end up bringing you down to the same number as your neighbor. So, for instance, if I chose this is 2, 5, this is 4, 4, this is 6, 3, this is 8, 2, I could either choose these two or maybe I chose 2, 5 and 6, 3. I would like for you to find the slopes for both of these, and I would like for you to give it to me in unsimplified form. So I would like for you to just give me the initial fraction before you simplify it. So in order to do that, maybe you struggle with plugging values into it. I could always label my values before plugging it into the formula. I know it's y2 minus y1, so that's 4 minus 5 over x2 minus x1. So that would be negative 1/2. And then I could do that over here as well. Maybe I don't need to label, so that would be 3 minus 5 over 6 minus 2, and that's negative 2 over 4. So these are your two fractions, your two slopes before you simplify them. This one is fully simplified. If I were to go to the next step and simplify this guy, we notice that this is also negative 1/2. So it really doesn't matter which points you pull, it should all simplify down to the same number because that's the whole point of a line is that the slope is constant. It is a constant rate of change. So it doesn't matter which points you're pulling because it will always simplify down to the same number on a line, not on other things. Okay. So here's our slope. We found it in 2 different ways. So we went a little above and beyond, but now hopefully we know a little bit more about slopes. I would like for you to go ahead and find the slope of B. These guys have got negatives, so I would bet if you were tripped up at all, it was probably just because of the negatives. I'm going to choose to do, this is x2, y2, x1, y1. A lot of times, even as a math teacher, it's just nice to have a process. It's nice to know first I label my variables, then I write out my formula, and it's something familiar. It's like a little safety blanket. So if you're somebody who likes a process, do this every time. It kind of feels like you've already had a few steps into the problem before you actually start the problem, and it kind of gets rid of some of those jitters maybe. This one's pretty straightforward, but it also works for those harder problems. Okay, negative 5 minus negative 11 becomes plus 11, and then 0 minus negative 2 becomes plus 2. So negative 5 plus 11 ends up being 6 over 2, and my slope is 3. 3 over 1, or just 3. Okay. Example 2. Delphina recently went to exchange her euro for US dollars. and her 21 euro exchanged for $24.81. Then later in the day, Greta purchased a new pair of boots for $113 and noticed that the bill on her credit card rang up as 95.66 euro. So we've got this relationship going on right now between dollars and euro. And a lot of times in our word problems in IB, we want to notice that if they're pairing numbers together, right? So they are pairing here a euro dollar amount. There's this in the same sentence, this idea of pairing these numbers together in both of these sentences. And so when they start to pair numbers together, if you notice in problems like this, word problems like this, that if you need to start analyzing, if you need to start representing a real world situation in a graphical or in an algebraic way, a very good first step is first just start making points. I put this question in here because I want you to always think about first, can I make points out of the data or information that I've been given? And you can. Let's let the euro be the X value and the dollar be the Y value. It could have been the other way around. It doesn't matter. But let's be consistent with that. So go ahead and write 2 points representing this situation. Okay, so this is a pairing of numbers, and then 113 to 95.66 is a pairing of two numbers. So my first point is going to be 21 euro goes to $24.81. And then I just need to make sure that I'm consistent, that my euro goes first. 95.66 euro is matched or paired with $113. So right now I've got these 2 points, and we're talking about, it asks us to find the gradient and then interpret the gradient in the context of the problem. It's asking us to treat this as a linear relationship, which all exchange rates are. All exchange rates are a constant rate of change. They may change from day to day, but the idea is in that day, no matter what value you're choosing, the exchange rate is going to be the same. Whether you're choosing really small numbers or whether you're choosing really big numbers, that rate stays the same in that day. So it's a linear relationship. So in order to find the gradient, I just need to go ahead and subtract these guys out. So I would do 113 minus 24.81 over 95.66 minus 21. I would like for you to go ahead and find that and simplify it down. We end up getting 1.18 as our gradient. And that's what the slope is. So then when it says to interpret this in the context of the problem, a lot of times with slopes, every time with slopes, if my answer is given as a number like this, which in a lot of real world problems it is, I like to think of it as a ratio over 1, because what the gradient really is this unit rate. And if you remember all the way back to like middle school math, your unit rate is when you bring down a fraction or a relationship. A rate is a fraction of something on the top compared to something on the bottom, and it's brought down to 1. And so it's saying that it's this much things, this many things per one of these things. And that's really what, anytime they ask you to interpret the gradient, is they want you to understand that it's 1.18 of whatever this unit of measurement is compared to 1 of the other unit of measurement. In order to know what the unit of measurement is, we have to remember what the fundamentals of the slope are. It's the change in your y values over the change in your x values. So in this case, the change in your y values is the change in your dollars. So this is 1.18 US dollars compared to the change in your X value, which in this case is the euro.